A very fresh good morning, everyone. Hello, welcome back to another session of your science class. I hope you all are fine, taking care of yourselves, and even preparing for your exams, your upcoming exams. In today's video, we will begin with a new chapter from your book, that is chapter number 15, Light. In today's video, we will discuss or we will talk only about few selected topics. So without wasting any time, let's begin.
How do we humans perceive the things around us? We have 5 senses that help us to interact with the world around us. These are sight, hearing, taste, smell, and touch. Eyes help us to see things, ears help us to hear sounds, we smell with our nose, taste with our tongue, and the sense of touch is provided by our skin. Of course, all senses are important, but the sense of sight is the most important. Here is an interesting fact. We perceive almost 80% of the world around us by using our sense of sight. We see objects around us with our eyes. But then why don't our eyes see these objects in the dark? The answer to this question is light. We are able to see the objects around us because of the light coming from these objects. The light from these objects travels in space and reaches our eyes.
When a beam of sunlight enters a dark room through a small hole, we can see the beam of light traveling in straight lines. When the headlight of a car is switched on, the light rays appear to travel in straight lines. Light travels in a straight line. This property of light is called rectilinear propagation of light.
Reflection of light. When a ray of light while traveling from one optical medium to another optical medium, say from air to glass, strikes the surface of separation of two media, is returned by the second optical medium into the first optical medium with a change of angle. The phenomenon is called the reflection of light. Any smooth polished surface can turn the rays of light back into the same medium is called a mirror. A looking glass is the best example of a mirror. Note that besides mirror, other smooth polished surfaces also reflect light. Polished floors and tabletops reflect light.
When we stand in front of a mirror, we see an image of ourselves in the mirror. The image formed in a mirror is a virtual image. An image that forms on a screen, such as the image produced by a projector, is a real image. An image that cannot be formed on a screen is a virtual image. There are 3 types of mirrors: plane mirrors, convex mirrors, and concave mirrors. A plane mirror has a flat surface. A convex mirror has a surface that curves outwards, and a concave mirror has a surface that curves inwards. The image formed in a plane mirror is upright and the same size as the object. The image formed in a convex mirror is upright and smaller than the object. When the object or observer is close to the mirror, the image formed on a concave mirror is upright and bigger than the object. However, when the object or observer is far away from the mirror, the image formed in a concave mirror is inverted and also smaller than the object. We see an image of the same object in the mirror because light rays from the object bounce off the mirror and reach our eyes. This makes it seem like the light rays came from inside the mirror. This process is called the reflection of light. For a plane mirror, the distance from the image to the mirror is equal to the distance from the object to the mirror.
What can happen when a beam of light is incident on the surface of any object? When a light beam is incident on the surface of any object, a part of the light can be reflected by the object, a part of the light can be transmitted. That is, it may pass through the object and get out from the other side, and a part of the light can also be absorbed by the object. The amount of light reflected, absorbed or transmitted depends on the material that the object is made up of. If an object is opaque, then it will absorb and or reflect most of the light back. If it's transparent, more light will be transmitted. Can you think of examples for these two? The surface of a mirror is shiny and opaque, and most of the light rays are reflected from it. On the other hand, glass is an example of a transparent object. It will transmit most of the light. So what is refraction of light? Here's how we define it in simple words. It's simply bending of light when it travels from one medium to another. Yes, if it is incident at this angle, then it goes through at another angle. Consider a transparent object kept here, say a glass slab. Suppose light traveling through air is incident obliquely on the surface of the glass. What do I mean when I say obliquely? It means slant. It implies that the incident ray is neither parallel nor at a right angle to a specified line. Now this light will bend at the boundary of the two media. Here, the two media are air and glass. This bending of light at the boundary of the two media is what we call refraction of light.
A lens is a transparent material through which light can pass. Lenses are widely used in spectacles, telescopes, microscopes, and cameras. There are two types of lenses, concave and convex. Concave lenses are thinner in the middle than at the edges, whereas convex lenses are thicker in the middle than at the edges. We must have used a magnifying glass to observe the body parts of an insect, or must have used it to read small prints. Have you observed its shape? Well, it is convex. Hence, convex lens is used as a magnifying glass.
So here we have a parallel beam of light, and this is a convex lens in my hand. Convex lens which is bulged outward from both the sides, and this is concave lens which is bulged inward from both the sides. Now let us find out the behavior of parallel beam of light in concave lens. When a parallel beam of light passes through concave lens, it diverges. As concave lens diverges a parallel beam of light, so it is also known as diverging lens. On the other hand, if I place convex lens in the path of parallel beam of light, the beams they converge at a point. As convex lens converges a parallel beam of light at a point, so it is also known as converging lens. And that's all for today. For further notifications, do like and subscribe.